All right, guys, let's see how far I can get before my battery dies. I'm at 14%, so wish me luck. All right, number 104, find the missing terms of the following arithmetic sequences. So because we know that it's arithmetic, we know that there's a common difference that takes you from term to term. So if I could just find that, then I could figure out what the missing terms are. So let's use this formula. A sub n equals a sub 1 plus n minus 1 times d. Okay, remember I'm looking for the common difference, so I should have everything else. So a sub n is going to stand for your last term here, so it's 115. A sub 1 is going to be your first term, which is 55. And then plus n is the number of terms, 1, 2, 3, 4, 5. So 5 minus 1 times d. So if I subtract 55 from both sides, I'm going to get 60 equals, and 5 minus 1 is 4d. If I divide by 4, I'm going to get that d equals 15. So if I add 15 to 55, that gives me 70. 70 plus 15 is 85. 85 plus 15 is 100, and 100 plus 15 is 115. I just found my terms. Okay, now 105 is very similar, except I don't know the first term and the last term. So what I told you in class today was just to kind of look at the sequence within the sequence. So look at just like the -6 and the 15. Okay, so same idea. We're going to use a sub n equals a sub 1 plus n minus 1 times d. So the a sub n is your last term, so that's 15. Your a sub 1 is the first term, so that's 6, plus the number of terms in these little brackets, 1, 2, 3, 4, so 4 minus 1 times d. Then if I subtract 6, I'm going to get 9 equals 3d, which gives me that d equals 3. So the common difference here, did I do that right? I feel like I did something wrong. Oh, I see what I did wrong. A sub 1 is not 6, it's -6. So let's try that again. I looked at it, I'm like, this is not going to work. Okay, if I add 6 to both sides, I'm going to get 21 equals 3d, which means that d equals 7. So if I add 7, -6 plus 7 is 1, 1 plus 7 is 8, 8 plus 7 is 15, 15 plus 7 is 22. Now to get this term, I'm just going to do the opposite and subtract 7, which is going to be -13. Okay? All right, number 106, find the fourth term in the geometric sequence. So because it's geometric, that means I'm multiplying to get from term to term. So my first term is 7. I need to find the fourth one. So if I multiply by 2, that's my common ratio. 7 times 2 is 14. 14 times 2 is 28. 28 times 2 is 56. Hope that's on your final. Okay, this guy right here, so a sub 1 is 6. And I want to find the seventh term. So 1, 2, 3, 4, 5, 6, 7. Okay, again, the r is 2. So if I multiply by 2, 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. Getting a little bit big here. 96 times 2, I believe, is 192. And 192 times 2, what would that be? Let's see, that's 418, 384, I believe. Okay, so you guys, on this one, let's see if we're in the seventh term. So 1, 2, 3, 4, 5, 6, 7. Yep, that should be your final answer. Okay, let's see, number 108, find the sum of the infinite geometric series. You guys, we only have one infinite sum formula, and that's a sub 1 over 1 minus r. So your a sub 1 is the first term, which is 25, all over 1 minus the common ratio. A little bit harder to find on this one, because like, what do you multiply 25 by to get 20? I really don't know. But remember the little trick I showed you? If you just look any two terms next to each other, the common ratio is going to be the term on the right divided by the term on the left. So that reduces to 4 over 5. So that should be your common ratio. So let's plug that in. And then if we could do this without a calculator, 1 whole minus 4/5 is just 1/5. But dividing by 1/5 is the same as multiplying by 5. So this should be 125. Okay, same idea for number 109. Find the sum of the infinite geometric series. Again, we're going to use a sub 1 over 1 minus r. So a sub 1 is 8 over 1 minus. Now, what do I multiply to get to 4? I'm multiplying by 1/2. I'm halving it, right? So this is 1/2. And then I know that 1 minus 1/2, sorry, this should be an 8. 1 minus 1/2 is 1/2. And if you divide by 1/2, that's the same as multiplying by 2. So that should be 16. Okay, 10. Find the sum of the first 150 terms. Now, in this one, definitely want to use a formula because that's a lot of terms. So first, I have to decide, is it arithmetic or is it geometric? Okay, so how am I getting from term to term? It looks like I'm adding 11, which means I'm arithmetic because I'm adding and not multiplying. So the arithmetic sum formula, make sure you have this one written down, is n over 2 times a sub 1 plus a sub n. Let's see if I have everything that I need. Remember again, the n is the number of terms. The number of terms is 150, that's your n. So I have a 150 divided by 2 times a sub 1 is the first term, which is 5. And a sub n, I do not know what the 150th term is. So I'm going to go to my other formula to find it. So my other arithmetic formula is a sub n is a sub 1 plus n minus 1 times d. So I'm looking for a sub n. So that's going to equal a sub 1, which is 5, plus n minus 1. Well, the n is still this 150 minus 1 times the common difference, which is 11. So plugging that into my calculator, I have 5 plus 149 times 11, and that gives me 1,644. So let's go ahead and plug that in for the a sub n. Going to help my calculator out a little bit. 150 divided by 2 is 75, and 1 plus 1644 is 1649. So multiplying those together, 75 times 1649, I got, oh yeah, my favorite answer, 123,675. All right. Okay, let's do number 11. So 11, same idea. Find the sum of the first 20 terms. Let's see if we're geometric or arithmetic. So again, to go from term to term here, I'm multiplying by 2. So since I'm multiplying by 2, I'm definitely geometric because I'm not adding. Okay, so the geometric sum formula is a sub 1 times 1 minus r to the n all over 1 minus r. Let's see if I have all of my information. Do I have a sub 1? Yes, I do. That's 6. That's my first term. 1 minus, my common ratio is 2. And the n is the number of terms, which is 20. And then all over 1 minus 2. Okay, so you guys, I'm going to type in this part first onto my calculator, the 1 minus 2 to the 20th. So let's do that. 1 minus 2 to the 20th. And for that, I got negative 10485. Okay. I'm writing with the highlighter. Sorry. Let's try that again. This is negative 1048575. And then on the bottom, I have 1 minus 2, which is negative 1. So that negative 1 really does nothing, but it does get rid of the negatives. So now I just have to multiply that number by 6. And I'm going to get 6291450. Definitely a calculator question. All right, 112. Okay, so sigma, right? Sigma means to add up. So I'm adding up the first 9 terms of this 2 to the n minus 1. Now the question is it arithmetic or is it geometric? Hey, if you can't tell, plug in a couple numbers and see what you got. Let me erase this. I made a mess of it. Okay, so if you plug in n equals 1, I'm going to get 2 to the 1 minus 1, which is 2 to the 0, which is 1. If I plug in n equals 2, I'm going to get 2. I'm just replacing this n, right? 2 to the 2 minus 1, which is 2 to the 1, which is 2. If I plug in n equals 3, I'm going to get 2 to the 3 minus 1, which is 2 to the second, which is 4. So how am I getting from term to term? I'm multiplying by 2, so I'm geometric, right? So the geometric sum formula, again, is S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So let's see what I've got. Do I know a sub 1? Yes, I do. The first term is 1. So it's 1 times 1 minus, the ratio was 2, to the n, that's the number of terms, which is 9, all over 1 minus r, which is 2. So again, just like before, I'm going to plug in the 1 minus 2 to the 9th first. So let's do that. So I have 1 minus 2 to the 9th, which is negative 511. This 1 does absolutely nothing for us, by the way. I keep writing with a highlighter. So this is negative 511 over 1 minus 2, which is negative 1. So that's just 511. All right, for number 13, because I'm going to infinity, the only infinity formula I know is a sub 1 over 1 minus r. So this thing has to be geometric for me to be able to use it. So a sub 1 is the first term. If I plug in n equals 1, I'm going to get 2/3 to the first power, which just gives me 2/3. And then all over 1 minus r. You guys, this is your common ratio. Like even if you looked at n equals 2, n equals 2 to be 2 to the third to the second power. So you're basically just multiplying by 2 to the third every single time. So if I do this in my head, I get 2/3 all over 1 minus 2/3, which is 1/3. And then dividing by a fraction is the same as multiplying by the reciprocal. So these cancel and you just get a nice little 2. Okay? All right, 114. So is it arithmetic or is it geometric? If you don't know, plug in a couple numbers. So if you plug in n equals 1, I'm going to get 2 times 1 plus 5, which is 7. If I plug in n equals 2, I'm going to get 2 times 2 plus 5, which is 9. And if I plug in n equals 3, I'm going to get 2 times 3 plus 5, which is 11. So I see that I'm adding 2 to get from term to term, which means I'm arithmetic. Okay, so the arithmetic sum formula is n over 2 times a sub 1 plus a sub n. So let's see what I've got. The number of terms is 20, so I'm going to have 20 over 2. The first term is 7. And then the last term, I don't know. I only found the third term. So to get the last term, I'm going to plug, what did I just do? Low battery. It's okay. It's 10% remaining. I can do it. Okay, I'm going to plug in 20. So that's going to be 20 times 2. Actually, let's write it the right way. It's going to be 2 times 20 plus 5, which is 45. Okay, now plugging this in, this is 10 times 7 plus 45 is 52. Multiplying that, I'm going to get 520. Okay, 115, let me do a different color because I'm kind of like getting all these colors mixed up. Okay, is it arithmetic or is it geometric? So if I plug in n equals 1, so again, I'm trying to find is it A or G. Okay, if I plug in n equals 1, I'm going to get 1 plus 4 over 2, which is 5 over 2, which is 2.5. If I plug in n equals 2, I'm going to get 2 plus 4 over 2, which is 6 over 2, which is 3. If I plug in n equals 3, I'm going to get 3 plus 4 over 2, which is 7 over 2, which is 3.5. So how am I getting from term to term? I'm literally just adding 0.5, so I'm definitely arithmetic because I'm adding. So same idea, let's use the arithmetic sum formula. S sub n equals n over 2 times a sub 1 plus a sub n. So the number of terms in this case is 100. So 100 over 2. The first term is this 2.5. And the last term, that's the 100th term. So I need to plug that in. That's going to be 100 plus 4 divided by 2. So that's 104 divided by 2, which is just 52. Okay, now putting this together, 100 divided by 2 is 50. 2.5 plus 52 is 54.5. So multiplying those together, 50 times 54.5, 2725. Okay? All right, let's look at 116. Write an expression in sigma notation. So you guys, this time, instead of them giving me the expression and finding the sum, they're giving me the series and they want me to write it like this, okay? So let's go ahead and write the sigma in there. I always want to start at n equals 1. You can really start anywhere, but it gets harder if you start in other places. So if I start at n equals 1, now I have to figure out how far to go. So this number up here is going to be the number of terms. Well, I can't really tell how many there are. There's 1, 2, 3, a whole bunch in between, and then this one. So I need to find out what the n is. So the question is, I'll put it up here, what is n? Okay, so to find it, first, is it arithmetic or is it geometric? Well, to go from term to term, it looks like I'm multiplying by 3. That means I'm geometric. So the a sub n formula for a geometric sequence is a sub 1 times r to the n minus 1. Remember, I'm looking for n, so I should have everything else. So let's see what I've got. The a sub n is my last term, which is 3, 6, 4, 5. Okay, the a sub 1 is the first term, which is 5. The ratio is 3, and then to the n minus 1. Now, if I want to solve this, I can divide both sides by 5. And then 3,645, 3,645 divided by 5. That's 729. Let me put that up here. So 729 equals 3 to the n minus 1. Now, to solve for n, I could take the log of both sides, or I can just see if I can get the bases to be the same. So I know that 3 to the 6th power is 729. It won't be that big on your test, equals 3 to the n minus 1. If I take these guys away and just set the exponents equal to each other, add 1 to both sides, I'm going to get that n equals 7. So kind of a lot of work to find out that this thing only has 7 terms, but it's okay. Now, the last thing I need to do is to find a formula, okay, in here, so that if I plug in n equals 1 into this formula, it spits out 5. If I plug in n equals 2 into this formula, it spits out 15, and so on and so forth. Now look, I know this thing is geometric, so I know the geometric formula is a sub n equals a sub 1 times r to the n minus 1. Because I want to be able to plug in the n's, I want to keep anything that has an n as an n. Do not replace the n. Okay, so look, this will be a sub n equals a sub 1, that's the first term, which is 5. The common ratio is 3 to the n minus 1. This is my formula, 5 times 3 to the n minus 1. And you can even check it out, like plug in n equals 1, plug in n equals 2. See if it's spitting out this series for you, okay? So there's your final answer. Okay, 117, write an expression in sigma notation for 15 plus 19 all the way to 43. Okay, so first, am I arithmetic or am I geometric? So how am I getting from place to place? It looks like I'm adding 4, which means I'm arithmetic. Okay, so sigma notation, n equals 1, 2. Remember, this top number, again, is the number of terms. And in this case, I can just count them. 1, 2, 3, 4, 5, 6, 7, 8. So it's n equals 1 to 8. And then let's find an expression for this. So since I'm arithmetic, it's going to be a sub n equals a sub 1 plus n minus 1 times d. Again, because I'm looking for something to plug n into, I want to keep anything that has an n as an n. Do not replace it. So I have a sub n equals, a sub 1 is the first term, 15 plus, keep the n as an n, and then the common difference is the 4. Okay, now let's just simplify a little bit. So if I distribute this, I'm going to get 15 plus 4n minus 4, which is 4n, and then 15 minus 4 is 11. So this right here, 4n plus 11. Look, if I plug in n equals 1, 4 plus 11 is 15. If I plug in n equals 2, 8 plus 11 is 19. Do you see how it's spitting out those terms for you? So there's your final answer. Now, you guys, I believe 118 and 119 were actually, we already did those. I think those were like 110 and something else, right? So we don't have to worry about these guys. We already did them. Okay, so you guys, the word problems, I just realized I did not attach them to here, so I'm going to have to upload that and do that on a different video, which is probably a good idea since I'm running out of battery juice anyways. So have a good night, and I'll see you guys tomorrow.